Okay guys, Mr. Burns here with your video for lesson 1.5T, rational and irrational numbers. So let's talk about what those types of numbers are. If you take the word rational and you take the word irrational and you break it down to its root word, the root word for rational and irrational is ratio. What's a ratio? It's a fraction, okay, that compares two terms. So one example of a ratio that you guys have seen in the past is like 3 halves, right? So 3 halves. Or 3 to 2, or 3 to 2. Okay, those are ratios. Remember that? Should be pretty easy. See if I can make those a little bit smaller. Set them off to the side. All right. Well, let's talk about what rational numbers are. Rational numbers are any decimals or whole numbers that can be rewritten as a fraction. One example would be like 3.5. Let's say you have 3.5. Okay, it terminates, it stops. The decimal doesn't keep on going on forever and ever and ever and ever. So if I was to rewrite this as a fraction or a mixed number, it would be 3 and 5 tenths. That would be an example of a rational number. Another example of a rational number, okay, would be something like, let's say, through 1/2. It's a ratio, it's a rational number, it terminates. If you were to change it into a decimal, it would be 0.5, okay, and it stops. It doesn't keep on going on forever and ever and ever and ever. All right, so that's a rational number. Irrational numbers are a little bit different. Irrational numbers are numbers that can't be rewritten as or written as a ratio of two integers. Those are irrational numbers. One of the most common irrational numbers that you guys see a lot is pi. So pi is approximately equal to, when you rewrite this as let me back up. Pi can be written as a fraction, 22/7. But if you were to convert that fraction to a decimal, it would be approximately equal to 3.14. And you'll often see these 3 dots, 1, 2, 3. Those 3 dots in Latin are called ad infinitum, which means it goes on forever and ever and ever and it doesn't repeat. So you can't rewrite pi, okay, as a simplified fraction. It's 22/7 or 3.14 ad infinitum going on forever and ever and ever. So those are irrational numbers. Okay, so it just basically can't be rewritten as a simplified fraction. Just an aside, if you look on your calculators, sometimes on your calculators it'll have this like a really fancy cursive E, which is called Euler's number. Okay, Euler's number is another really fancy irrational number, and it's approximately equal to 2.7182 . Okay, another one you'll see is the golden ratio. Oops. Almost got that right. It's like something off of Harry Potter. So the golden ratio is another irrational number, and it's approximately equal to 1.6180 ad infinitum, because it goes on forever and ever and ever and ever, and it doesn't repeat. A lot of square roots, if you look on your calculator, you just pick a number, right? If you find the square root, the cube root, okay, whatever of some numbers, a lot of those numbers are going to be irrational, which means they can't be rewritten as a simplified fraction. Okay, all right. So that's rational, irrational numbers. Let's go ahead and dive right into the worksheet. All right. So for number 1, it says complete the number line below to show integers and perfect squares. So you did this on the previous assignment. I believe it was lesson 1.4. Okay, you kind of, in lesson 1.4, we talked about that a little bit, and we completed a chart there. So let's go ahead and do this again. So on your number line, you'll see it's got integers from 0 all the way to 12. And then above that line, they want you to put the squares of those, so the perfect squares of those numbers. So in this case, what's 1 times 1? 1 times 1 is 1. Okay, oops, choose a different color that shows up. 1 and square root. Okay, square root of 1 is 1. Square root of 4 is 2. Square root of 3 is 9. Okay, the square root of what is 4? So what number? So when I take 4 and I multiply 2 itself, what do I get? I get 16. So square root. And let me make this a little bit bigger so it's a little bit neater for you guys. Okay, what's 5 times 5? 5 times 5 is 25. Okay, square root. And you just complete the chart. 7 times 7, 49. Most of you guys are pretty smart. 9 times 9 is 81. Okay, let me see if I need to go on. Yes, I do. So 11 times 11 is 121. Square root of that. Okay, and 12, what's that? It's 144. Square root. So there we go. There's our number line that shows both the integers, okay, on the bottom, okay, and their perfect squares up top. All right. Moving on to number 2. Now, number 2 is a little bit funky because you've got both positive and negative integers. So in number 2, it says, complete the number line below to show integers and their perfect cubes. All right, so this is going to be, take a little bit more explanation before I do the chart. So if I have negative 5 and I'm finding its perfect cubed, I'm going to take negative 5 cubed and I'm going to rewrite it as a multiplication problem. So what that means is it's negative 5 times negative 5. I should put this in parentheses, actually. Boop, like that. So please write what I write. So it's negative 5 times negative 5 times negative 5. Now, what's negative 5 times negative 5? If you remember your rules for multiplying positive and negative numbers, this will go by pretty quickly. If you don't remember the rules, go back and review. Look it up on the internet, okay? Google's a wonderful thing. Internet searching is a wonderful thing. But a negative times a negative number is positive. So negative 5 times negative 5. See if I can shrink this. Nope, I can't. So negative 5 times negative 5 is positive 25. Let's see if I can do this. Okay, so it's positive 25. And then positive 25 times negative 5 is what? That's negative 125. Okay, so negative 5, okay, and its perfect cube is negative 5 times negative 5 times negative 5, which is negative 125. Now, when you rewrite this, it should look like this. So cube root of negative 125. Okay, so if I write it, you write it. It'll make it a little bit easier to understand. Okay, so just to review, kind of carry on the lesson here. So if you've got negative 4, whoops, not squiggly, but if you've got negative 4 and you cube it, it'll be negative 4 cubed, which is the same as, don't forget my parentheses, negative 4 times negative 4 times negative 4. Negative 4 times negative 4 is 16. And then negative 16 times negative 4, okay, is negative 64. All right, so there we go. Let's see, negative 2. So negative 2, if I were to cube that, so if I said negative 2 cubed, it would be negative 2 times negative 2, which is 4. And then 4 times negative 2 is negative 8. Okay, and then it's cube root. And then next, negative 3. So if I go negative 3 and I cube it, negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. Okay, so there we go. Again, if the videos go a little bit quick, slow me down. Okay, slow it down, go back, review, listen again. Don't just write the answers, please. All right, here we go. 2, cube it, so 2 cubed. 2 times 2 is 4, 4 times 2 is 8. Perfect cubed should be written as such. Okay, number 4, so you got 4 cubed, which is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Cube root. Complete your chart. Number 5. Number 5 cubed. Okay, so 5 times 5 is 25. 25 times 5 is 125. And there you go. So again, you know, you've got your integers below. There's your integer, and there's your perfect cube. All right. Okay, let's talk about 3, 4, and 5. So your instructions for numbers 3, 4, and 5, it says, use the number lines above to help compare each set of values And then it says fill in each box with the greater than, less than, or equal sign to make each sentence to make a true statement. So remember the rules about comparison signs. The mouth of the hungry alligator wants to eat the bigger chicken. Okay, so the mouth of the hungry alligator wants to eat the bigger chicken. So the mouth, okay, the open part, is going to be towards facing the bigger number. Another way you can think about this is the arrow is always pointing towards the smaller number. So, whatever it is, whatever floats your boat, okay, and helps you to remember. Here we go. Number 3. Number 3, again, we're going to use a chart at the top. Number 3, they want us to compare 30 and 4 3/4. So when we're comparing these numbers, you got to think to yourself, what two perfect squares is 30 closest in between? So you've got the one below, the perfect square number just below 30 is 25. Okay, the other perfect square number that 30 is in between is 36. When I rewrite those, okay, as their integers, the square root of 25 is 5, and the square root of 36 is 6. So if I compare these two numbers with this number, okay, the square root of 30 being between 5 and 6, what do you think? What's smaller? Okay, 4 3/4 or the square root of 30? Well, 4 3/4 is smaller than 5 or 6, so therefore the square root of 30 is going to be larger than 4 3/4. Hopefully that makes sense to you. Moving on to number 4. Okay, for number 4, they want you to take the cube root of negative 60, the cube root of negative 60 and negative pi. So the cube root of negative 60 is in between what two numbers? That's going to be, if you look at your chart above, negative 60, okay, is going to be somewhere in between the cube root of negative 27 and the cube root of negative 64. When I rewrite these, the cube root of negative 27 is negative 3, and the cube root of negative 64 is negative 4. Now, before we start to talk about, which one's greater, whether it's, the cube root of negative 60 or negative pi, we have to ask ourselves, the cube root of negative 60, what is that closer to? Is it closer to negative 3 or negative 4? Well, we have to look at the number 60. What is negative 60 closer to? Negative 27 or negative 64? It's actually closer to negative 64. Okay, so when we compare that to negative pi or negative 3.14, okay, which one's going to be the larger number? In this case, the larger number is a number that is closer to 0. So negative pi is actually going to be closer to 0. Okay, so the cube root of negative 60, okay, the cube root of negative 60 is actually going to be less than or farther away from 0 than negative pi. Let's go ahead and move on to number 5. Okay, on number 5, they're getting a little trickery with us. So here we go. We've got the square root of 7, and they want us to compare that to the cube root of 7. So let's see, let's find two perfect square numbers that 7 is closest or is in between. So the one that's just below that is the square root of 4, and the one just above that is the square root of, 4 and 9. Okay, 7 is closer to 9, but let's see. So the square root of 4 is 2, and the square root of 9 is 3. Now we got to do the same thing with the cube root of 7. So what's the perfect cube just below 7? That would be the cube root of, 1. And the cube root, okay, of 8. All right. 7 is closer to 8, but let's see. So the cube root of 1, not approximately equal to, but equal to 1. And the cube root, okay, of 8 is 2. And we also have to ask ourselves, what is 7 closer to? Is 7 closer to 1 or is it closer to 8? It's actually closer to 8. And since that's the case, what number is bigger, 3 or 2? 3 is bigger than 2. So the square root of 7 is actually going to be larger than the cube root of 7. All right? Hopefully this makes a little bit of sense to you. If it doesn't, just keep working with me, and at some point, it'll click. I promise you, the light bulb will go off and it'll start making sense to you. All right, let's talk about 3, 4, and 5. Sorry, we just got done with 3, 4, and 5. Let's talk about 6 and 7. So in 6 and 7, they don't want us to compare. They want us to order each list of numbers from least to greatest, and we are going to use the chart at the top, okay, for numbers 1 and numbers 2. So what I'm going to suggest you guys do is also use a calculator. Okay, use a calculator when you're doing this, and hopefully it'll make it a little bit easier for you guys. But you can also use the charts. All right, so let's go ahead and let's get this started. So number 6. So at number 6, if you find the cube root of 64, so I'm sorry, 65. So the cube root of 65 is approximately equal to 4.020. So I'm going to go 4.020. Now, it's going to be really important that you watch what I do, and there's a reason why I do what I do. So I'm going to stack the decimal points because that will help me when it comes to comparing these decimals. So the next one, 3.89, is already written as a decimal. So watch how I write it. So 3.89. I say 3.82. I meant 3.89. So line up the decimal points. I promise you it'll make sense here in just a minute. And then if I convert 7 halves to a decimal, so 7 divided by 2, so 7 divided by 2, you should come up with 3.5. So 3.5. Now, looking at these decimals going from left to right, they ask us to compare them, to compare them and order them from least to greatest. So going from left to right, what's smaller, 4 or 3? 3 is smaller. So these two decimals are smaller than 4.02. Now, in the ones place, you got the same number, 3. So we can't tell which one's smaller. We go to the right of that. What number is smaller? Is 8 or 5 smaller? 5 is smaller, so therefore that decimal is the smallest. So 3.5. Okay, after that, the next smallest decimal is 3.89. And then after that, the largest one is 4.02. And I should say this is the smallest, that's the next largest, not smallest, and this is the largest. Sorry. Okay. And for the bottom part, then it says write the numbers from smallest to largest, use the original numbers. So the original number, the smallest number is 7 halves. So let's go ahead and rewrite that in its original form. So it's going to be 7 halves. The next number after that, is going to be 3.89. And the next number after that is the cube root, so the cube root of 65. Hopefully this is making sense to you. All right, let's move on to number 7. On number 7, you have negative square root of 19. Then you have negative 11 thirds. And then you've got the cube root of negative 112. All right, again, use your calculators. So if I find the square root of negative 19, I come up with negative 4.35. Now, for the next one, it says convert negative 11 thirds to a decimal. So when you do that, so you go 11 divided by 3, you actually end up with negative 3.66, repeating. And then the cube root of negative 112. So if you do that on your calculator, so it's actually negative. Oh, you know what? I messed up. I didn't line up my decimals. So it's negative 3.66, repeating. And then again, back to the cube root of negative 112. When you do that, you actually get negative 4.82. All right. Now, comparing negative numbers, It can be a little trickery and a little confusing, but hopefully it'll make more sense to you. Smaller negative numbers are actually farther away from 0 than larger negative numbers. So, here we go. Let's compare these. So you've got negative 4.35, negative 3.66, and negative 4.82. So in this case, let's start off in the ones place and move our way over. So in the ones place, what number is bigger? Is it negative 4 or negative 3? Well, negative 4 is larger. So since negative 4 is larger, those decimals are actually going to be farther away from 0, which means they're actually, quote, smaller, right? So I can't really tell which one's smaller, negative 4, negative 4. So let's take a look at the tenths place. So looking at the tenths place, what number is larger, 3 or 8? 8 is larger. Therefore, since we're dealing with negative numbers, that number is farther away from 0, so it is actually smaller. So the smallest of all of these is negative 4.82. After that, you've got negative 4.35. Okay, and the largest of all of these negative numbers is negative 3.66 because it's actually closer to 0. Let's go ahead and rewrite these in their original form. So negative 4.82 is actually the cube root of negative 112. Negative 112. After that, you've got the square root, or the negative square root, okay, of 19. And the largest of all three of these numbers is negative 11 thirds. All right, let's go ahead and jump on to the next page. Okay, for number 8. Number 8 says, find the approximate value of each expression and plot each value on the number line. So when we're doing these types of problems, when we're dealing with the square roots and cube roots, you have to keep in mind the order of operations. The please excuse my dear Aunt Sally bit, right? So when you're dealing with square roots and cube roots, it's actually throws another wrench into that. So the first thing you have to do is you have to find the cube root or the square root first as an operation before you do any other operation. So again, take care of the square root signs or the cube root signs first before you do anything else. So for part A it says, what's the cube root of negative 23 minus 1? So the first part says estimate the cube root, or estimate the value of the cube root of negative 23. Use a calculator. So if you go 23 and you find the cube root, it's going to give you a positive. So put 2.84 positive, right? Well, since it's negative, guess what? It's negative 2.84. So in this case, I'm going to rewrite this up at the top. So it's going to be negative 2.84. At this point, you're going to subtract 1. So negative 2.84. So on your calculator, if you go 2.84 plus or minus sign, and you subtract 1 more, okay, you're going to come up with negative 3.84. Okay, so I had to go from here to here. So negative 2.84 minus 1 more is actually negative 3.84. And then it says locate the approximate value on the number line below and label it A. So starting at 0, negative 3.84, which direction do you think we're going to go? Are we going to go to the right? Those are all positive numbers. And we're going to the left. Those are all negative numbers. So negative 3.84 is 1, 2, negative 3. And then 8.4, just approximate, right? So it's going to be right about there. And then label it A. Hey, 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 it's A. You know what to say. All right, moving on. Part B says, what's half of the square root of 110? So again, take care of the square root first. So if you go 110, find its square root, you get 10.48. So it's going to be 1/2 of the square root of 10.48. And what's that equal to? Approximately. It's approximately equal to 5.24. All right. So it says multiply the estimate by 1/2. Okay, we already did that up here. Okay, so what's the final answer? 5.24. And where's that on the number line? If I start from 0, I go 0, 1, 2, 3, 4, 5. And 5.24 is kind of like there. So I'm going to label it B. Okay, to be or not to be? That is the question which so preoccupies my mind. All right, next one, C, 2 times pi. Well, pretty easy peasy lemon squeezy, I should think. So let's go ahead and take 2, and we're going to multiply it by the numeric value of pi, which is approximately equal to 3.14. And 2 times 3.14 is 6.28. Again, trust but verify, use your calculator. Okay, so on the number line, starting off at 0, I'm going all the way to 6.24. So here's 6, and 0.24 is like right there. So then you label it C. All right. Part D says 5. Now this is a little bit funny. So it's 5 minus the square root of 27. So here we go. When we rewrite this, it's going to be, I'm going to write above because I'm running out of room. So it's going to be 5 minus the square root of, 5 minus the square root of 27, which is 5.19. So 5.19. And when I subtract those, so 5 minus 5.19, that is actually negative 0.19. Again, trust but verify, use your calculators. So negative 0.19 on the number line is going to be in between 0 and negative 1. So let's say right there, right? So that's D. All right, and then let's see. E. E says, the way you read this is it's 2 times the cube root of 2. So let's go ahead and set this up. So it's going to be 2 times the cube root of 2, which is 1.25. And then 2 times 1.25 is 2.50. All right. And then when we get that, go ahead and plot that on a number line. So starting off at 0, so we're going to go 1, 2 to the right, and then 2.5 is right in between 2 and 3. So this is E. All right. I'm hoping this makes sense to you guys. If you're having a hard time, you're struggling, again, go back, listen to it again. And sometimes when you listen to things over and over and over again, at some point, it clicks. There's a light bulb that goes off. I promise you that it will. Anyways, if you guys have any questions, you know what to do. Okay. Let me know. That's all I got. Mr. Burns, out.